Good evening, good morning, everyone. Today's lecture, we are probably going to deal with friction, static friction in this case, and we are going to wind up your this chapter hopefully today with friction done. We might take one more class to do inertial, non-inertial reference frame. Let us see. In this particular class, we are going to deal with static friction. Before going on to static friction, let us have a quick recap of what we had done in the previous class. In the previous class, we had seen the kinetic friction or dynamic friction, and we had seen that the kinetic or the dynamic friction, the value is always mu k into n. If you want to change the value of friction, you have to either change the value of mu k or you have to change the value of n. We had also seen how do you find out the contact force. We have already seen what is the angle of friction. We have already seen what is the angle of repose. Yes or no? No, yes.
Yes, sir.
We had also seen some problems where we had found out the frictional force, and we had seen that the problem still remains same. The only thing that gets added up is that we have to use friction as one of the forces. Yes or no?
Yes, sir.
On the same category, what we'll do is we will do one more problem, and which is nothing but a continuation of the problem that we did when everything was smooth. So I'll just put that problem for you, and now we will try to do it in a new insight. The insight which tells us what happened, beta? Everything okay?
Yes, sir.
Okay. Now I made this problem where I have two blocks, one of 5 kg hanging and one of 10 kg, which is put on a block, which is put on a surface. This surface is now not smooth, but it's rough, and the coefficient of kinetic friction is mu k. Can you now find out what is the acceleration of the blocks? Obviously, you have to find out the other thing, what is the frictional force and all those things, but the main point is, can you find out the acceleration of the two blocks? I'll give you 2 minutes to do this. Just better. Do we get this? Shall I do it for you?
No, sir, we are doing. Just give some more time.
Let me solve it for you. I don't think it should take so much of time. So let me solve it for you. I'll draw the free body diagram. This is 50 newtons.
50, yes, sir.
This is T. Tension here is T. This is 100 newtons. Normal reaction is N. This block will go down. This block will go here. So frictional force will act in the backward direction, Fk. If you look at this normal will be equal to 100, yes or no?
Yes, sir.
So frictional force will be 100 multiplied by 0.2. How much will be that? 20 newtons.
Sir.
Now I make the equation. I look at this, I look at this, and I look at this. What is the equation of this block?
50 minus T is equal to 5A.
50 minus T is equal to 5A. Well done. Then I look at this one, this one, this one, and this one. What is the equation for this block?
Fk minus 20 is equal to, 100 minus 20 is equal to 10A.
T minus 20 is equal to 10A. Do we get this?
Yes, sir.
Do you understand what mistake we are making?
Yes, sir.
When you add these two equations, you will get the value of A. Once you get the value of A, you should be able to get the value of T and so on. It is as simple as it gets. Do we understand this? Yes or no? No, yes.
Yes, sir. Yes, sir.
Anyone having any doubt on this?
No,
Please
sir.
ask.
Got it, sir.
Okay, please see what mistake you are making. Probably you are making equation in a different direction, and that is the problem. Okay, shall we move ahead in life? In life, we have to always move ahead. I'll give you 2 minutes to note it down.
Done, sir.
Okay, sir. That takes us to the next topic, and the next topic is known as static friction. Static friction. Now, what is this static friction? Anyone? What is this static friction? Have you heard about static friction?
Yes, sir.
What is static friction? Tell me. What is static friction? This friction comes up between two bodies. This is the friction between two bodies. When there is no motion or when there is no RM. What do you mean by RM?
Relative motion.
When there is no relative motion, but there is a, and the word we use is tendency of motion or tendency of relative motion. Static friction opposes the tendency of relative motion. Static motion opposes the tendency of relative motion. The magnitude and direction of static friction varies depending on in which direction the body is moving or supposed to move. The magnitude and the direction of static friction changes. Do we understand this?
Yes, sir.
Take an example. If I have this inclined plane at an angle theta, and if I have a block of mass m and this block of mass m is at rest. It is not moving. What will be the direction of static friction? Why it is not moving? First of all, tell me. It should move. It should accelerate. Why it should accelerate? Because if I draw the free body diagram, this is mg, this is mg cos theta, this is mg sin theta, and this is normal reaction n. This normal reaction n is equal to mg cos theta. But then there is mg sin theta, which is trying to push it downward, pull it downward. But as you can see, I have written it at rest. It does not move. Why it does not move? Something must stop it. What is stopping it? It should move. It is not moving. What is stopping it? Static friction is stopping it. The direction of static friction is upwards, and the value of static friction in this case will be mg sin theta. Static friction is the friction that happens, that comes between two bodies when there is no relative motion, but there is a tendency of relative motion. I'll give you 2 minutes to note it down. Once you are done, please let me know. If you have any doubts, please ask me. Anything that you don't understand, beta, please feel free to ask me.
Okay, sir. Done, sir.
Okay, so the magnitude and direction of static friction is not constant, but there is a maximum value of static friction that cannot be exceeded. There is a maximum value of static friction that cannot be exceeded. The maximum value of static friction, and static friction is written as Fs, is known as limiting friction. The maximum value of static friction is known as limiting friction, that is known as Fl, and the value of this Fl is fixed, that is equal to mu s into n. This mu s is a constant which depends on the two bodies in contact, and the value of this mu s, and this mu s is known as coefficient of static friction. Do we understand this? Yes or no? No, yes.
Yes, sir.
The value of this mu s is always more than mu k. It is known as, we call it in this way, static friction is always more than kinetic friction. It is difficult to start the motion of a body, but when the motion starts, it becomes easier. It becomes easier to continue that motion. Do you understand this? So, what I can say in general, for a body, 0 is less than or equal to Fs is less than or equal to Fl. This Fl is nothing but equal to mu s multiplied by n. Have you understood the meaning of this? The value of static friction is not fixed. It varies.
Yes, sir.
It varies from a minimum value, which may be 0, to a maximum value. The maximum value of static friction is known as limiting friction. Do we understand this? Yes or no?
Yes,
No,
sir.
yes. If you want to change the value of this limiting friction, there are only two ways to do this. What are the two ways? Either you change the value of mu s, either you change the value of mu s, or you change the value of,
Of n.
or you change the value of n. You can only do two things. Either you change the value of mu s or you change the value of n. This is the only way to change the value of limiting friction. Limiting friction is always constant. Do we understand this?
Yes, sir.
Okay. Have you noted this down?
Done, sir.
Let me give you an example. A body is kept on ground. Mass is 5 kgs. And I'm applying a force of 10 newtons on the body. The body does not move. The body remains at rest. Obviously, the floor is rough. Can you tell me what is the value of what type of frictional force is acting on the body and what is the value of the frictional force? What type of friction is acting on the body and what is the value of that frictional force? Difficult?
Sir, value is 10 Newton.
Value.
Kinetic friction is acting.
I have straight away written that the body is at rest. When does kinetic friction come into the picture, beta?
Sorry, sir. Static friction is.
The friction is static Fs. It will be acting in the opposite direction Fs, and that will be equal to 10 newtons. Do we understand this, or this has gone above our head saying bye bye? Do you understand this? Yes or no? Everyone understands this? Let me now change the question and I increase the force to 15 newtons. And I still find that the body remains at rest. Again, ask you the same question. What is happening now? The body is not moving. Who is stopping it from moving?
Static friction.
Static friction is stopping it from moving. What is the value of that static friction?
15 Newton, sir.
Now, the static friction has changed its value and now it has become 15 newtons. So you can see the static friction can change its value. It can also change its direction. If I apply force in the opposite direction, static friction will change the direction as well. Do we understand this? Yes or no? No, yes. Or it has gone above our head saying bye bye. I'm going. Don't worry about me. I'm gone. You understand this? So static friction can change its magnitude. It's intelligent friction. I call it that way. That this friction is an intelligent one. It can change its magnitude. It can change its direction. Now let us say I take the third case and I take the third case and I write it like this. Again, I am just making a fictitious case. I put a force of 20 newtons, and this is the word that we use. The body is just about to move, or it has just moved. The body is just about to move, or it has just moved. What type of friction is acting now on the body when the body is just about to move?
Kinetic friction.
The body is just about to move. What type of friction is acting on the body? The body is just about to move.
Kinetic
All
friction.
this type of friction when the body is just about to move is known as friction has reached its maximum limit, and we call it limiting friction. The body has not moved, but it is just about to move. That means the friction has reached its maximum value, and friction has reached its maximum value. Do we understand this? Yes or no? No, yes. It has gone above our head saying bye bye. I'm going. When the body is just about to move, we say that the friction is has reached its limiting value. Do we understand this? Yes or no? Do we understand this? Yes or no? This is the word that we use. What is the value of limiting friction now?
20 newtons.
The value of limiting friction is 20 newtons. From here, you can calculate the value of mu s. Tell me the value of mu s. From here, my dear friends, you can tell me the value of mu s. Please tell me the value of mu s.
0.1, sir.
How did you get it as 0.1?
Sir, it is FL by normal reaction.
FL by normal reaction, because FL is mu s into normal reaction. So normal reaction is 50, yes or no?
Yes, sir.
So it will be 20 divided by 50, 2 by 5, 0.4. We got this, yes or no? Okay. Now let us take the next case. Now when the body has just moved, friction changes from static to which range? Friction changes from static to kinetic range, and the value of mu k is always less than mu s. Do we understand this? Yes or no? We understand this?
Yes, sir.
Let us say that the value of mu k is 0.5 times mu s. Now I'm still applying the same force, 20 newtons. Can you now tell me what is the acceleration of the body? You will say acceleration, sir. How it is accelerated? See what has happened. I hope you are getting the question. Yes or no? No, yes. Are we getting the question, my dear friends?
Yes, sir.
So we are trying to make sense of static friction. We are trying to make sense of limiting friction. And we are seeing what happens. How does the motion of the body start? How does the motion of the body start? We have increased the force slowly, 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 slowly. And then the motion of the body has started. I hope we are understanding this. Yes or no? No or yes? Can you now tell me the acceleration of the body, my dear friends? I'm awaiting your answers, dear. To
2 meter
understand
per
this,
second square, sir.
If you understand this, that means you have understood the concept of static, kinetic, and limiting friction. That would be a good beginning, I must say. Probably a good end, because that finishes the chapter on static friction as well. Yes, my dear friends, do you understand this?
Yes, sir.
As I said, as I told you, bacha, it is difficult to move a body, but when it starts to move, it is easier to continue the motion. Remember, we needed 20 newtons of force to move the body, to start the motion. But now, with 20 Newton force, we are able to continue the motion. Do we understand this?
Yes, sir.
So now I can write this thing. This is 50 newtons. This is N. Now the body has started to move, so I can write friction as kinetic, yes or no? And kinetic friction is constant, 0.2 multiplied by mu s. Mu s is 0.4. So mu k becomes 0.2, yes or no? No, yes.
Yes, sir.
0.2 multiplied by 50, it is 10 newtons, yes or no? Fk
Yes,
is 10 newtons, yes or no? I look at this, the body is going to accelerate in this direction, yes or no?
Yes, sir.
I can write the equation 20 minus 10 is equal to 5a. It is now going to move with an acceleration of 2 meter per second square. With the same force, I am now able to accelerate the body. The same force was required to just move the body. Now I am able to accelerate the body. How is that possible? What has made it possible, my dear friends? What has
Kinetic,
made it possible?
kinetic friction.
Kinetic friction is less than static friction, and that is why this entire thing is possible. Do we understand this? Yes or no? No or yes?
Yes, sir.
Now, if I can draw a graph between this, for this particular case, when the body is kept, the graph would look like this. Do we understand this graph? At first, whatever force I was applying, the same was static friction. Yes or no?
Yes, sir.
So here we see applied force and here we see static friction. The body does not move. What is this angle? How much will be this angle between the applied force and static friction? Both are equal, so angle would be 45 degrees. Do we understand this?
Yes, sir.
Up till this point, the body does not move. That means it is in static range. Do we understand this?
Yes, sir.
And the value of friction has become maximum FL. Do we understand this?
Yes, sir.
After this point, the friction key value decreases. Why does it decrease? Because it now becomes Fk and the body starts to move. Do we understand this? Yes or no? No or yes?
Yes, sir.
I'll give you 2 minutes to note this down. Are you done?
Yes, sir.
Why are you waiting? Why can't you tell me that you are done, beta? We don't have time that we can sit and relax and look at the stars and the universe and feel good about it. Don't have that much time. So if you are done, please tell me. I thought you are writing. Please tell me that you are done so that I can move ahead in life, beta. There are a lot of things that I have to do. Can't just sit here like this. Do we understand this?
Yes, sir.
Static friction. The maximum value of static friction is fixed. The minimum value can be 0. So remember, whenever there is a motion, to start the motion, we must go till limiting friction. Yes or no?
Yes, sir.
Okay. So this is a question that I am going to bring up for you. Just to start things off, remember, every question on static friction is tricky because we don't know the value of friction. So this is question number 1. Now, sometimes it is only given that the coefficient of friction is 0.3. It is not said whether it is mu s or mu k. So what you should do is, if it is moving, you can take it as mu k. If it is not moving, you can take it as mu s. Do we understand this? Normally, both mu k and mu s should be given to you, but to confuse you, they will not tell you whether it is mu s or mu k. They will just give you as mu. Then you will have to understand, should I take it as mu s or should I take it as mu k? So you must then find out whether the body is having relative motion or not. If it is having relative motion, it is mu k. If it is not having relative motion, it is mu s. What is the maximum force of friction available between the ladder and the floor? You must have seen, you sometimes put a ladder and sometimes it slips. What is the maximum force of friction that is available on the ladder? And what is the answer?
Sir, it is Fs, mu s.
Okay, so what is the value? I'll give you 1 minute. Give me the answer fast.
75 Newton, sir.
75 Newton, sir. How did you get the answer, sir?
Sir, the maximum force of friction is at F limiting, sir.
Right.
And here the coefficient of friction is mu s.
Okay.
So mu s into this normal force is 75, sir.
Okay. So basically what you have done is you have calculated mu s into n. Yes or no? No, yes.
Yes, sir.
Well, that is correct. So I hope you have understood the concept. Whenever someone says maximum friction, he is basically talking about static friction or limiting friction, because we have seen from the diagram also that the maximum value of friction is the limiting friction. Yes or no? No, yes.
Yes, sir.
If you remember these small things, you can do a lot of great things. Can I move on to the next question? Fatafat, sata, sat. Remember, these are the ways in which questions are asked, and probably if you are lucky enough and you do enough questions enough, same question will appear in the exam. This is the next one that comes. A block of mass 2 kg is kept on a floor. The coefficient of static friction is 0.4. So force of 2.5 Newton is applied on the block. What is the value of frictional force? What is the acceleration? They can ask you what is the acceleration. They can ask you what is the value of friction force. Doesn't matter. The concept remains the same. I shall give you 2 minutes to solve this. Once you are done, please let me know the answer that you are done. Don't have time to sit.
Sir, it's done.
What, bacha?
Sir, it's 2.5 Newton, sir.
Is 2.5 newtons. How did you get the answer as 2.5 newton, bacha?
Sir, F limiting is 8 Newton, sir.
F limiting is 8 newtons, sir. Well done, sir. So,
Force is less than 8 Newtons.
well done. That is
So-
correct. Force
So
is less than
body will
8.
be at rest.
Body will be at rest. Well done. Correct.
The frictional force acting on is static force. Sorry,
Frictional
static
force
friction.
acting on it is static force. Well done. So you have thought about all the scenarios. You have first found out whether it can move or not. How do you find out whether it can move or not? The only way you can find it out is by finding the value of limiting friction. Is the limiting friction, is the force more than the limiting friction? And you can see that this force is not more than limiting friction because you can find out the value of limiting friction. Yes or no? No or yes?
Yes, sir.
How do you find out limiting friction, my dear friends?
Mu s into normal reaction.
Mu s into normal reaction. That is how you find out limiting friction. What is mu s? Mu s is given as
0.4.
0.4. And what is the value of normal reaction? 20.
Yes, sir.
20 into 0.4 will be 8. So limiting friction is 8. But the force that is trying to pull it only 2.5. It cannot accelerate. That means it will remain at rest. If it remains at rest, the friction is static and it must equate the force which is applied 2.5 Newton. That is the answer, my dear friends. Yes or no? No, yes, we got this.
Yes, sir.
Huh? So remember these type of questions. These type of questions may look very tricky, but they in fact are very simple. And I'll give you one more on this. The more the number of questions that you are going to solve, my dear friends, the better you are going to become. So here comes the next question. And I shall give you 2 minutes to solve this. Let me know once you are done, my dear friends. Because if you don't know, we keep on staring at the stars.
Sir, the answer is A, 0.38.
The answer is A, 0.38. How did you get it?
Sir, here 75 Newton is required to set the block in motion.
So that must be equal to what, bacha?
That is F limiting.
That is F limiting. Well done. So F limiting is 75 newtons. Okay. That must be equal to mu s multiplied by n. Yes or no?
Yes, sir.
N is how much?
Sir, 200 Newton.
So mu s is 75 divided by 200. Whatever you get is the answer. Do we understand this?
Yes, sir. Yes, sir.
Everyone understand this? What are we doing? Yes or no? No, yes.
Yes, sir.
Okay, let me find out another question for you. Not here. This is from your module. Let's see if you can do this. Simple things. You do them simply. You get your answer simply. Tell me the answer for this.
Sir, is it 0?
Is it 0? Yes, it is 0. How did you get 0?
F limiting is 50 Newton, sir.
F limiting is 50 newtons. So if F limiting is 50 newtons and the force that we have applied is also 50 newtons, it's just about move. Do we understand this? It will have no acceleration. Do we understand this? Yes or no? No, yes.
Yes, sir.
Everything is about F limiting. So whenever you see a block which is initially at rest and then they ask you what is the acceleration, you must always think about limiting friction. Do we understand this? Yes or no? No, yes.
Yes, sir.
Please think about this. Once more, last one for today. This should be the way a question should be put. Both the values must be given. I await your answers on this one. Find the acceleration of the block. Initially, the block is at rest. Give you 2 minutes. Let me know when you are done.
Sir, it is 3.57 meter per second square.
It is 3.57. No, it is not correct. Check it again.
Sir, is it 2.1?
It is 2.1, my dear friend. 2.1 meter per second square. That is absolutely correct. And how did you get it?
Sir, I had taken kinetic friction, sir.
Why you have taken kinetic friction? There must be a reason for anything, everything.
Because the force applied is greater than the limiting friction, sir.
The force applied is greater than the limiting friction.
So the object
The force
is
applied is greater than the limiting friction. So
at motion, sir.
the object will be moving. If the object is moving, then
It
what
will be
do
acted
you
by
do?
kinetic friction, sir.
There must be kinetic friction onto it. So how do we do this? First of all, we find out the value of FL. What is the value of FL coming as? It is mu s multiplied by n. How much is that? Mu s is 0.5 multiplied by this is n is 100. So this is 50 newtons. The applied force is more than 50 newtons. So it is going to move. Once it moves, the friction is kinetic in nature. So now you have to find out the value of Fk. Fk is mu k multiplied by n. So now it becomes 0.3 multiplied by 100. Now it becomes 30 newtons. It drastically comes down. Now backward force is 30 newtons. Forward force is 51 newtons. It is going to accelerate in the forward direction. The equation will be 51 minus 30 is equal to 10a. From there, you will get A as 2.1 meter per second square. Do we understand this? Yes or no? No, yes.
Yes, sir.
Well, everyone confident about static friction, kinetic friction? Do you understand the difference? There are questions, some questions given in the sheet. Please try those questions. By Sunday, you should be able to finish majority of them. Monday class, we will take one class on that non-inertial frames. We will do that and then we will move on to the next chapter, the more interesting one, work, power, and energy. If you have any doubts, please come up to me and ask them. Please try questions. The more the number of questions that you try, the better you are going to become. So I'll end this class on this note. Take care. Have a nice day. God bless you all.